In this video, we're going to be looking at completing the square. So first of all, what is completing the square? Well, completing the square is a method of writing a quadratic function in a particular format. So, for example, here we've got the quadratic x squared plus 6x minus 3, and this can be written in this way. So x plus 3 all squared, take away 12. And this is the completed square format. And what we're going to learn to do is just learn how we can simply start with the quadratic expression on the left and turn it to the quadratic expression on the right. Just to prove it works, what we can do is we can expand out the brackets, x plus 3 squared, subtract 12 from it, and then hopefully we get the same answer as we started with. So if you remember the process of expanding brackets, you multiply everything in the first bracket by everything in the second bracket. So when I go through the process here, I end up with x squared plus 6x plus 9. So that's just the bracket expanded. Now, if I subtract 12 from that, so x plus 3 all squared take away 12 is equal to that expression we just worked out, take away 12, which gives us x squared plus 6x, take away 3, which is what we started with. So we've justified that this is right. So how does this work? Well, it's actually quite a straightforward process, and you've got to learn a few little tips on here. So we start with the quadratic expression. The key parts to it are the number of x's and the constant term at the end. So in this case, the 8 and the negative 2. All I have to do is I have to add half the number of x's, and I write it in my bracket like this. So I have x plus 4 all squared. I always then subtract, and whatever that number, half of the number of x's was, in this case 4, we're going to square it. And then we take away 2, so that bit hasn't changed. So the 4 has come because that was half of the number of x's. Okay, and we repeat it again a second time. We always take away whatever that number is squared. Now all it's a case of doing is it's working out the right hand side of this expression. So x plus 4 squared, take away, well, 4 squared is 16, and take away another 2. Again, the 2 is unchanged. And then we simplify it, so we get x plus 4 squared, take away 18. And we have completed the square. Let's look at another example. X squared plus 10x plus 31. So again, exactly the same as before. We halve the number of x's, which is 5. So x plus 5 squared, and then we always take away that number squared. And we're going to add on 31 because that remains unchanged. That's the thing to remember. That doesn't change until the very end. We then work out a little bit on the right hand side by squaring the 5. So we've got to take away 25 plus 31, and then we simplify it. So x plus 5 squared plus 6. A third example, this time we got a subtraction. So x squared minus 6x minus 13. Now half of negative 6 is negative 3. We still take away, but this time we're taking away negative 3 squared. And then we take away 13. So this is really important to recognise it's a negative 3 because half of negative 6 is negative 3. And again, our negative 13 remains the same. So this comes x, take away 3 all squared, take away 9, take away 13. Now remember, negative 3 squared is negative 3 times negative 3, which is positive 9. And simplifying this, x take away 3 squared minus 22. So example 4. This time I've got an odd number of x's. When I come to half negative 5, I'm going to write it as negative 5 over 2. So I have x take away 5 over 2 all squared, take away negative 5 over 2 all squared plus 2. So my method is exactly the same as before, except I'm using a fraction. So when I write it out, First bracket's unchanged. Now the second one, when I square out the 5 over 2, the negative 5 over 2, it gives me 25 over 4. But it's still take away, remember. Okay, and then negative 25 over 4 plus 2 is negative 17 over 4. And I can use a calculator for that if need be. Now, it's much better to use fractions than it is to use decimals when we're doing this. Now, what's the uses of completing the square? Well, one of the things we can do is to find the turning point of a quadratic curve. Now that is the point when the curve is a U shape, so it's effectively the bottom of the U. So here's an example. Let's say I've got a quadratic curve, y equals x squared plus 10x take away 13. And I want to complete the square, just doing what we've done before. So halving the number of x's, taking away that value squared, and then taking away 13. And it gives me y equals x plus 5 all squared take away 38. Now the graph itself looks like this. I know it goes through negative 13, and I know that from the initial equation. It's the constant term it goes through on the y-axis. So the bit I'm interested in is this at the bottom here, and I know this is going to be the point negative 5, negative 38. That's called my turning point, the bottom of the U. And if you look where the numbers have come from, with the negative 38, it comes from there. And the negative 5, if you solve the bracket equal to 0, so x plus 5 equals 0, you get x equals negative 5. And that is the x value of the turning point. So let's look at a second example here. Y equals x squared minus 7x minus 1. So exactly the same as before. We've got fractions here, so we're going to work with our fractions, but we're using our standard method of doing this one. Squaring out, subtracting 1, and we're going to end up with x minus 7 over 2 all squared, take away 53 over 4. Now I know from looking at this that the turning point, I solve the bracket equal to 0, and that's going to give me 7 over 2. And the bit at the end is the y coordinate, is negative 53 over 4. Okay, so this is just showing how I've got the x value. So if I want to draw this out, I can actually sketch this a little bit more accurately now. So I have some axes. I know the turning point is 7 over 2, negative 53 over 4. So I know roughly speaking which quadrant it's going to be and where the bottom of the U is going to be. I also know it's going to go through negative 1 on the y-axis because that's the constant term which we got from the initial equation. And just as a sketch, no scale, I'm able to draw out what the picture would look like. Now the second use that we can use completing the square for is to find the equation of the line of symmetry of a quadratic curve. Now we know that a quadratic curve is a U shape, and the line of symmetry is simply the line that goes vertically down the middle of the U. So here we have a quadratic, y equals x plus 3 all squared, take away 4. We know the turning point of this from what we previously discussed, so that's going to be the point negative 3, negative 4. And the line of symmetry is simply the line that goes straight up through the middle of it, which would have the equation x equals negative 3. Effectively, to do this, all we're actually having to do is take the bracket x plus 3, make it equal to 0, and then we have to rearrange it to make x the subject. So obviously we do that by subtracting 3 from both sides, and we end up with x equals negative 3. Now clearly you don't have to go through the process of that, you should be able to look at that and see what the answer is going to be, remembering basically that the sign of the constant term in the bracket is going to change.